Okay, let's do this one more time. And we're going to do one where we have to find the concentration of an unknown that has a coefficient. All right, you'll see what I'm talking about. Let's try this one, okay? So this one says find the molarity of a calcium hydroxide solution given that 428 mils of the solution is neutralized in a titration by 115 mils of 6.7 times 10 to the negative third molar HNO3. So remember that our first step is always to find moles of the known. So it's up to us to determine which of these two solutions is the known. In other words, which one do we already know the concentration? Well, they give it to us right here. So we know that HNO3, which is a regular old acid with one H plus, has a concentration of 6.7 times 10 to the minus third molar. So we're going to take our equation for molarity from chapter 12, right? You remember this one, molarity is equal to moles over liters. And we're going to flip this around to find moles. It's equal to molarity times liters. Well, we know the molarity, 6.7 times 10 to the minus third molar. And we're going to take this 115 milliliters and we're going to get it into liters. You can do that a couple ways. You can move the decimal place over 3, or we can simply divide it by 1,000. So 115 divided by 1,000, and this is our volume in liters, 0.115. So how many moles do we have? We'll take our calculator and we'll say 6.7 times 10 to the minus third molar times 0.115 liters. Here you go. 7.7 times 10 to the minus 4 moles, okay? That's how many moles of HNO3 we have. All right, our second step, okay? We're going to dissociate this known. What we mean by that is we're going to say, okay, we know that HNO3 dissociates into H plus and NO3 minus. We know we have 7.7 times 10 to the negative 4 moles of HNO3. How many moles of H plus is this? Well, there's no coefficients, there's no subscripts, so this is basically a 1. 7.7 times 10 to the negative 4 moles of H plus, and we're not worried about the NO3, but if someone was curious, you would tell them the exact same amount. We're not worried about that. Okay, this part is the easiest because H plus and OH minus are always equal. That's the point of a titration. You're neutralizing. Every H plus you have, you're neutralizing with an OH minus. So if you have 7.7 times 10 to the negative 4 moles of H plus, you're going to need 7.7 times 10 to the negative 4 moles of OH minus. All right. This is where things get a little different, but don't panic. We're going to reassociate our unknown. Okay? We know that we're dealing with something called calcium hydroxide, right? Calcium hydroxide. Okay? We know that calcium hydroxide, when it dissociates into calcium and 2 hydroxides. That's what that little subscript tells us. All right. We already know, I'm changing colors so you know that this is serious. We already know that we have 7.7 times 10 to the negative 4 moles of hydroxide. We already know this. So we're trying to find this, which means we're going this way. Now, the best and fastest way I know how to explain this is that if we are going this way, we divide by any coefficients we have. If we were doing it the other way, if we were going, say, from the reactant side to the products, we would multiply by any subscripts. Okay, well, we're not going this way. We're not going from reactants to products. We're going from products to reactants. So I'm going to erase this. And let's go back to blue. We have 7.7 times 10 to the negative 4 moles of hydroxide. We're going towards the reactants, so we're going to divide by coefficients. Let's bust out our calculator, and we're going to say, oops, I hit the clear button. We're going to say 7.7 times 10 to the negative 4 divided by 2. There we go. This is our molage of our reassociated unknown. 3.8 times 10 to the negative 4, 3.85. Let's round that up to 3.9 times 10 to the negative 4. That is this. So what we're going to do now is finish the problem by saying, okay, if our unknown was 428 mils, what's our concentration if there are 3.9 times 10 to the negative 4 moles? So molarity equals moles over volume. You know 3.9 times 10 to the negative 4 moles of calcium hydroxide. This is 428 mils. We're going to divide that by 1,000, 2.428 liters. And let's bust out our calculator. We'll say 3.9 times 10 to the negative 4 divided by 0.428. This is our final answer. What's our concentration? 9.11 times 10 to the negative 4 molar calcium hydroxide. That's all we do, ladies and gentlemen.